Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about subgroup. In our previous classes, we clearly discussed about a group and its examples. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, first we are going to understand the definition, but with example, you are going to understand it better. Let's take the definition. A non-empty subset H. You take a subset H of a group G. You take a group G. G is having some set of elements. From that, you pick some subset of elements. That subset we call it as H. And this H we call it as a subgroup. When we are going to say it as a subgroup, if H itself is satisfying the group properties. What's the properties? 4 conditions are there. Closure, identity element, inverse and associative. If it satisfies these 4 under the same operation defined on G, whatever the binary operation you defined on group G, the same binary operation applied to subgroup H. If it satisfies the 4 conditions, then we say it as H is said to be as a subgroup. And the second condition it has to satisfy, H has the same identity element as G. G is having some identity element. The same identity element should be present in the H also. If it satisfies these 2 conditions, then we say it as a H is considered as a subgroup for group G. Let's take an examples and understand. The first example, Z plus. What is the group here? Z. What is the binary operation here? Plus. It is a subgroup of R plus. R means set of real numbers. It contains both integers and fractions. Minus infinite to plus infinite. What is the binary operation? Plus. Z means only integer values. Z is a subset of R. Yes, Z is subset. Z means only integers. R means both integers and fractions. And plus, this Z plus is a subgroup of R plus. Yes, it is accepted. Why it is accepted? We already know R plus is a group which satisfies the 4 conditions. What's the 4 conditions? It is having a closure property, it is having associative property, identity element is 0. The same identity elements we are having for Z also. For plus, identity element is 0. So why it is 0? These basics we discussed previously. Multiple examples we have done. We are not again explaining it. So Z plus is also satisfying closure property. You take any 2 integers. If you add them, you are going to get an integer. Yes, it is satisfying the closure property. Similarly, associative. Plus is always satisfies the associative property. Third one is identity element. What is the identity element for Z plus? 0 is the identity element. What is the identity element for R plus? 0 is the identity element. Both is having the same identity element. And inverse, for any integer value you are having an inverse. If you take 2, minus 2 is the inverse. If you take 5, minus 5 is the inverse. So Z plus is a subgroup of R plus. Similarly, we do one more example. The set of even numbers is a subgroup of Z plus. Z plus means only integer values. Take only integer values. From that, the subgroup contains only even numbers. Yes, even numbers contain 0. So, the set of even numbers, even number plus even number, you are going to get even number. So, it is satisfying closure property. It plus always satisfy associative property. Identity element is 0 for both Z plus and set of even numbers. Inverse is same. If you have 2, minus 2 is also even number. So this is the set of even numbers is a subgroup of Z plus. Similarly, the next example, the set of non-negative integers is not a subgroup of Z plus. In Z, you are having minus infinite to plus infinite, all the integer values, but set of non-negative, only positive integer values. So only positive integer values means you are going to get 1, 2, 3, 4, 5 up to infinite. 0 is not added in the positive integers. But we are missing identity element here. 0 is the identity element for both the sets. So we cannot find identity element here in this set of non-negative integer values. That's why this is not a subgroup of Z plus. And one more important point you need to understand, for any group, you take any group G star, some binary operation, definitely you are going to have one subgroup. What's that subgroup? E, identity element comma star. Yes, it is definitely this accepted as a subgroup. It is a subgroup, it is a guaranteed subgroup. This we call it as trivial subgroup. Why it is a subgroup? E, identity element. E, binary operation E, you are going to get E. In our last class we discussed the properties. E, binary operation E, we are going to get E. So it is satisfying the closure property. It is having identity element. E itself is an identity element for this group and this. What is the inverse of E? E itself only. So it is having all the properties, all the conditions, it is satisfying all the conditions of a group. This is the trivial subgroup for the group G. You take any group, you are having definitely one subgroup, that is this one. Hope you understand the concept of subgroup. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.